Hi everybody, today we're talking about the laws of logs again. We've talked about power law. Today we're just bringing in two more laws. One is product law and the other one is a quotient law. For power law, remember when we had our answer to the exponent, we were bringing the exponent to the front, just like it's here. Log a of m to the power of n, we were bringing n to the front. Sometimes we'll need to move it back to where m is, but you'll see it later. So product and quotient laws of logs come from the product and quotient laws of exponents. Remember, when we were multiplying the bases with exponents, but the base was the same, you could keep the base and add the exponents. Same thing was for division. You would divide the bases with exponents, bases that were the same. You would keep the base and subtract the exponents. For logs, log of a, when you multiply for the same base, when you multiply the answers, it's the same thing as adding logs of the answers. And when you're dividing the log of the answers, it's the same as subtracting two logs of two answers. The base, though, should remain the same. You have to always make sure that the base is the same. For the proof of the product law, we have to substitute m with a to the power of x and n with a to the power of y. Then we'll get m times n is the same thing, and it's a to the power of x times a to the power of y. Because the base is the same, we can add the exponents. Now we're going to bring in the logs, just like we did in the power law. In the lesson before the transformations. Log of a of mn equals log of a to the power of x plus y. Now if I remove the log of a from here, because the bases are the same, I'm just going to stay with, I'm going to be left with x plus y. So log of a of mn equals x plus y. And then I'm going to substitute back, and I'm going to see that if I express this in terms of the exponents, I'm going to get m equals a to the power of x, where x is the exponent, log of base a of answer m. And I do the same thing for n, and then eventually I'll get log of a of mn equals log of am plus log of an. So every time you see log of a number plus log of another number with the same base, you can bring it to a single log of the product of the two numbers, of the two answers. Alright, the quotient law works very similar, and you pretty much do the same process in terms of proof, except now we're going to be working with division, and that division is going to be turning into subtraction. Let's look at this. So I'm going to substitute my m with log of a of x and n with log of a of y. From here, a to the power of m equals x, because I use the properties of logs, where a is the base, x is the answer, m is the exponent. And I do the same thing for a to the power of n equals y. And then if I divide x over y, is the same thing as dividing a to the power of n over a to the power of n. And if I'm dividing the same bases with the exponents, I'm going to keep the base and subtract the exponents. Then, if I want to divide log of the base of x over y, I'm going to equal it to log of a m to m minus n power. The bases are the same, and I'm going to use the power law. I'm going to bring this exponent, m minus n, over to the front, and I'm going to get rid of log of a because it's going to give me nothing. Log of a of x over y equals m minus n, and then m was represented by this expression, and n was represented by this expression. I'm going to substitute it back in, and I see that log of the base of two answers divided by each other is going to be the difference of logs of those two answers. So here we are. We got two proofs of the laws, and now we're going to see how we can actually use those laws and how they are helpful. Alright, so if I have an expression So if I have an expression where I need to write this big expression as a single log, 2 log A plus log 3B minus 1/2 log C, I want to express it as one single log. The first thing I want to do is I want to move this 2 and this 1/2 back to where they were initially, because I used the power law to bring them to the front at some point. Now I want to move them back because it's going to make my life easier and it's going to help me simplify my expression. So this 2 came here from A. It was an exponent for A, so I'm going to bring it back here. Log A squared plus log 3B, I'm just keep it the way it is, and minus log C to the power of 1/2. Now, log A squared plus log 3B can be expressed as a single log using the product law, because if I'm adding 2 logs with the same base, I can just express it in terms of one log and multiply the answers. So log 3b times a squared, or 3a squared b. And I still have my minus log square root of c, because c to the power of 1/2 is the same as c square rooted. Now this is now a quotient law. When I'm subtracting 2 logs, it's the same thing as a single log with 2 answers divided by each other. 3a squared b divided by square root of c. And this is my expression expressed in terms of a single log with a one base. Okay. We can also use log laws to evaluate the expressions. So if I have a sum of 2 logs with the same base, I can use the product law to actually evaluate it. So log 6 of 9 times 4 equals log 6 of 36 equals 2. Sorry, there's a mistake here. It should be 2. It's not 6. So because I raised my 6 to the exponent 2 to get 36. Same thing happens here, except now we do the quotient rule. Log 2 of 144 divided by 9 equals log 2 of 16. So I raised my 2 to the power of 4 to get 16. My answer is 4, because this is the exponent that I raised my 2 to get 16. If I want to use the power law, again, and I have log 2 of 32 to the power of 1/3, I'm just going to bring this 1/3 over to the front, find the log of 2 of 32, which is 5, because 2 to the power of 5 gives me 32, and multiply it by 1/3, and I'm going to get 5/3, and that's the answer. Okay, in some cases, the expressions before or after we find their simplified value, we also need to determine the restrictions, because they won't be true, they won't be defined for every single x value. Because for log functions specifically, x has to be greater than 0. For exponentials, y has to be greater than 0. Why? Because of the asymptotes. Okay, so we have an expression log of 2x minus 2 subtract log of x squared minus 1. I'm going to simplify it and bring it to the single log. This is a quotient rule. I have a difference of logs, but the base is the same, so I'm just going to divide the answers. So log of 2x minus 2 divided by x squared minus 1. I'm going to factor out the 2 at the top in the numerator, and I'm going to split it into difference of squares. Again, factor the bottom. And I'm going to cancel out x minus 1's, and I'm going to get log of 2 over x plus 1, and that's my simplified expression. However, this expression is only going to be true for certain values of x, and I want to find what those x's are. Because I know that my x has to be greater than 0, we cannot take log of 0, for example. For this expression to be defined, both log terms must be defined. So I'm going to take the first term, 2x minus 2, and I'm going to take the second term, x squared minus 1, and set them to be greater than 0. So 2x minus 2 has to be greater than 0. X in this case has to be greater than 1. X squared minus 1 has to be greater than 0. X has to be greater than 1 or less than negative 1. But we have two expressions, so we only have to take the overlapping value of the x's that are true. Take x is less than 1, we can only take x is greater than 1. So in our expression, log of 2 of x plus 1 is true when x is greater than 1. Okay, this is it. These are your laws. There will be no more. There are only 3 laws. You need a lot of practice to be able to do them because there is a potential for small mistakes. Please practice and ask any questions when you come back to class tomorrow. See you soon.